In this video, I'll show you how to prove trigonometric identities using half-angle identities. The question reads, prove the identity shown below. I have a list of useful identities to the left, so we might use them. And in fact, we'll start to use them here, where we have sine squared x over 2. Now, this is the same thing as saying sine x over 2 all powered to 2. With that in mind, if I use the sign of half-angle identity, shown here, I can switch this part so that it looks like this, where I have the square root of 1 minus cosine x over 2 to the power of 2. We all know what happens when you square a square root. The square root disappears. So this goes away, and this 2 goes away, leaving us with, in the numerator position for the left-hand side, 1 minus cosine x all over 2. And of course, don't forget this plus 1. And in the denominator position, I can use the cosine of half-angle formula shown here, where I can convert this part into this part. Remember, the square root will disappear eventually. I don't need to show that twice. Giving us 1, that part hasn't changed, plus 1 plus cosine x over 2. Now, since we're trying to model the left side to look like the right side, right now it's totally different than the right side, I'll just keep this right side vacant. I'll continue working on the left side. What I'll do next is find a common denominator here and here, which is not hard to do. The common denominator here will be 2, and the common denominator here will also be 2. Essentially what we're doing is we're combining these two terms, 1 plus this and 1 plus that. Having done that, you should end up with a quotient on the top and a quotient at the bottom. Let's start with the numerator. 2 is the common denominator. 2 times 1 is 2. And pretend that there was a 1 there. 1 times this expression gives us that expression. Similarly, the same thing can be said about the bottom, except that the only difference is this negative, where we end up with 2 at the bottom. 2 times 1 is 2, plus 1 plus cosine x. Once again, we're trying to model this to the right side, but we're almost there. The quotient at the top and the quotient at the bottom both share the same denominator, which means we can cancel that out, leaving us with this as the numerator and this as the denominator. Also, these two terms can be combined, and so can these. Combining 2 plus 1 in the numerator and denominator position, we get 3 and 3. Now let's look at the right side. What does this expression look like? It looks like the right side, which means that we have proven that the left side is in fact equal to the right side, and that is how to prove trigonometric identities using half-angle identities.